How many of you think they're going to have the same volume? Raise your hand. How many think the cone is going to have more volume? How many think the cylinder is going to have more volume? You are absolutely correct, right? It kind of makes sense. Like, look, you can even put the cone in there. Like, the cylinder definitely has more volume. But now here's the trickier question. How much more? Specifically, how many cones do you think it would take to fill up this cylinder? Like, if I fill up the cone and pour it in, how many fill-ups do you think I would need? More than one, right? Because the cylinder's bigger. Do you think it's 1.5, 2, 2.5, 3, 3.5, 4, 5, 10? How many times do you think I would need to fill that up? Write your prediction on the corner of your paper. All right. How many people predicted 5 or more? Anybody? How many people predicted 2? 2.5? 3? 3.5? 4? All right, well, let's see. We're going to actually do it and see. So, I've filled up the cone, pouring it in the cylinder. That's one. Alright, now I've filled up the cone again. I'm going to pour it in the cylinder. Oh, that's 2, but it's still not full to the top, is it? Alright. Now I'm going to fill up the cone one more time. Alright, now my cone is filled. I'm going to pour it in the cylinder. Ta-da! Cylinder is filled. Number of cubes needed to fill something. That's what volume is. So everybody who said you thought it was 3 times, you predicted right. Very good job of estimating. Alright, so now that we saw a physical demonstration, let's go to our notes. So first thing we're going to do is write down what it is we just observed. Right? The volume of a cylinder is 3 times the volume of a cone. You just watch that happen. So we took a cone, we filled it up 3 times to make a cylinder. So the volume of this cylinder is 3 times the volume of this cone. But what I really want to know about is I want to know about the volume of a cone. So, Little side story here. I'm going to tell you, I have a brother, and my brother is younger than me, but he is a foot taller than me. I'm 5'4" and he's 6'4". So we have a joke, right? I call him my little brother because he's younger, and he calls me his big sister, even though I'm way shorter. But our relationship goes in both directions, right? So if I'm talking, I say, this is my little brother. But if he's talking, he's going to say, this is my big sister. Hello? Yes, absolutely. You're welcome. So, we have a relationship, right? But when I'm talking about the relationship, I'm saying, this is my little brother. When he's talking about the relationship, he's saying a big sister. Because the relationship goes in a different direction for each one of us. Well, math kind of works that way too. If this cylinder right here is 3 times this cone, right? And so the cylinder says, I am 3 times the volume of the cone, then the cone would say, I am what times the cylinder? Is that going to be 3 times? No. What's the other way around from multiplying? Dividing, right? So if this one is 3 times bigger, this one is going to be divided by 3. But what number do we write when we're dividing by 3? Dividing by 3 is the same thing as multiplying by... Think about it this way. If I take a candy bar and break it in 2 pieces, how much does each person get? Half, right? Break it in 2, you get half and half. Well, what if you break something in 3? What do you get? How much? Not a half. So if I have a candy bar and I break it in 3 pieces, how much is each one? You guys following? If I have a candy bar and I break it in half, it makes 2 pieces. Half and half, right? Well, if I break it in 3 pieces, how much is each one? 1/3. Because what does the number on the bottom of a fraction do? It divides, right? So if you divide by 3, that's the same as timesing by 1/3. So we would say the volume of a cone is 1/3 times the volume of a cylinder. It's 1/3 times as much. Which really means it's going to come out smaller, right? It's going to be like it's divided by 3. Okay, so here's how that relates to our formula chart. If you look on your green formula chart, and you look under volume, for pyramid or cone, it says volume equals 1/3 area of the base times height. Well, look right here. Area of the base times height, that's for the prism or the cylinder. So if you have a cone, it's the same as the cylinder times 1/3. If you have a pyramid, it's the same as your prism except times 1/3. And if you're like, why is that 1/3 there? Because we poured it, right? That's the relationship. A cone holds 1/3 as much of a cylinder that has the same radius and height. So, the problems that we're going to do today are going to be just like the ones we did yesterday, except everything is going to have to be times 1/3. That's going to be the only different part of the formula. Alright, so let's do an example together. Let's start with a cone. Let's make it a little more interesting. Alright, so there's my cone. So my formula is going to say volume equals 1/3 area of the base, capital B for area of the base, times height of the cone. Alright, so remember, the first thing we do is talk about that capital B, that area of the base. So what shape is our base? Our solid is a cone, but the base is a circle. So we have to find the area of a circle formula. Circle area pi r squared. So for our volume, we're going to write down 1/3 times pi times, now I need to put in r squared. Oh, well, how much is r? This number is 13. R is how much? 6.5. Right? Remember, R is for radius. This 13 is going all the way across. That's the diameter. The diameter divided by 2 equals the radius. So we're going to do 1/3 times pi times 6.5 squared, and then times the height of the cone, which is 11. Alright, now IXL is going to want us to use 3.14. So for our practice, let's go ahead, when we type the pi in, let's just type in 3.14. So everybody grab a calculator. If you didn't pick one up when you came in the room, grab one now. Alright. One way to get 1/3 on your calculator is just to do 1 divided by 3. That's 1/3. Okay? Another way is you can do alpha y equals, and it'll make your little fraction box for you. Some of you like it better to be like that. You can do 1/3. And then times 3.14 for pi. And then times 6.5. And that radius has to be squared. So we're going to square that. And then times 11. And I think that on IXL it says to round to the hundredths most of the problems. So let's also round to the hundredths. Your hundredths is 2 places after your decimal. So if my calculator has this number on it, I would round to 486.44. Because I look to the right of the 4, and there's an 8. 5 or more raise the score. Alright. Does that make sense? Alright, let's do another shape. Let's do a square pyramid. Let's start by drawing a square. Alright, so sometimes when I draw the 3D objects, you have to make sure you have the right perspective there. So that square's down on the bottom, right? That's our base. So it's coming up to a top here. I should have made that be a dashed line, probably. So this is a square pyramid. Now how do I know it's a square on the bottom? You see your little congruent markers? I didn't put them on the other side, but I've got a quadrilateral and all four sides are congruent. So if this side is 7 meters, this side is 7 meters. So I have a square pyramid. So my formula for a pyramid's volume is 1/3 area of the base times height. So that's going to be 1/3 times, now my base is a square. If I look at my formula chart, you might be like, Miss Collier, it doesn't even have a square. Well, all squares are rectangles, right? So base times height works for square as well. So that's just 7 times 7. So that part is the capital B. That's the area of the base. Times the height of the pyramid. The pyramid is 8 meters high. Alright, so grab your calculator. One-third times 7 times 7 times 8. Now it gave me my calculator as a fraction because I had my fraction button. IXL is going to want us to have a decimal answer. So for that I'm going to go to math. I'm going to tell it to make it a decimal. And then I'm going to round to the hundredths place. 130.67.